Welcome to day 2 of Vox Days Bucharest 2019. And yeah, I don't have any much things to say, so please welcome Mark Heckler. And have a nice day and enjoy the rest of the conference.
Well, good morning, everyone. That was terrible. Good morning, everyone. That's better. Okay. Must have taken a sip of coffee in between. All right. Well, hey, so this is day 2. Well, do you count workshop day? Anyway, this is the last day of Vox Days Bucharest, which is a little sad, but this is going to be an awesome day, right? Yes. Yes. Wow. Okay. This is kind of a quiet crowd. I'm not sure how to deal with this. Well, let's just get started because I have a lot of material that I want to cover, and they said I only have 3 hours. So this is going to be a push, but we'll do the best we can. I am going to actually, because there is, who here was in my session yesterday? Oh, wow. Okay. Well, there's a lot of material that actually is covered in both, right? So I'm going to cover some of the high points that I covered yesterday, so please bear with me with that. And then I'm going to kind of launch into the more practical aspects. Yesterday I kind of looked at the forward-leaning kind of future look. This is just getting down and dirty, rolling up the sleeves and getting busy with the actual current implementations and where it can really pay off for you. So that's kind of where we're going. So there will be a lot of overlap in terms of the setup and some of the code, but watch because I veer off in a different direction, and I think you'll like this. So we'll see. We'll find out. So welcome to this morning's keynote on drinking from the stream, or how to use messaging platforms for scalability and performance. I'm Mark Heckler. Those are my coordinates if you need to reach me, want to reach me. As always, Twitter is the best way to reach me. I check email, but not that regularly. From time to time I do. But Twitter is kind of where I live, right? If I could have my, 2 pieces of mail that I have delivered a year to me, delivered to Twitter, I'd do that too. But that's the best way to reach me. Open DMs, so you can shoot it out in public if you have a question, comment, or feedback, or you can DM me. That's fine. It's all good. So distributed systems are easy, right? Which is a little surprising to me anyone's here, right? Because they're so easy. So we might as well just go get coffee. Okay, maybe not. So distributed systems are a bit challenging, but there are certain patterns we can employ and tools and components we can employ to make our lives a lot easier, our systems a bit more robust, shall we say. And you might be wondering, who am I? Why am I pseudo-almost qualified to speak on this topic? Again, I'm Mark Heckler. I've co-authored a couple of books. I've contributed content and code to several other books, a few of which even recognized me, which is really nice. But I wasn't going to plan on living on the royalties anyway, so it's all right. It's just good to be in there somewhere, to borrow a movie line. I'm kind of a movie buff and retro TV buff, so if I throw out some weird, obscure reference and you don't get it, it's probably, you're not alone. Probably most people don't. If you're curious, ask me. I like to share. I am an architect and developer, and as you might guess from the next point, where most of my expertise has been won, it's been in the Java ecosystem. Most of my time has been spent over the last several years developing in Java. It's not a monogamous relationship, though. I do dabble in Kotlin. And if you haven't played with Kotlin, I would suggest you start, because it's an awesome language and it works really well with Java. But today we're going to stay primarily with Java, so nobody freak out. I am a professional problem solver, not officially by title. I just like the title, and it kind of summarizes everything I do pretty well. And I am a Spring developer and advocate with Pivotal. Pivotal are the makers of such fine software components as Spring Framework, Spring Boot, Redis, RabbitMQ, Greenplum, Gemfire, huge contributor to Apache Tomcat, huge contributor to the Cloud Foundry Common Code Line. Most of all of that, actually, that I just mentioned is open source. And everything that I talk about and show you today is open source, so you can download the bits and play with them. You can download the repos and start kicking the tires and looking through the code. Please do. If you see anything that's missing, you have questions about, again, we engage. It's all community-driven. So, okay. Very quick overview and kind of recap. Oh, the water fought back. See, this never happens with coffee. I'm feeling a little decaffeinated here this morning, so here afterward we'll grab some coffee and talk some more. In the interest of time, I'm going to make a few necessary assumptions, but again, I lay these out as assumptions, doesn't mean they're universal. If you have any questions about where I'm coming from with them, please see me afterward. I'm happy to discuss them. Or if you don't catch me anytime today, again, I live on Twitter, MKHeck. For starters, I'm going to assume you understand the benefits of moving in whole or in part from a monolithic architecture to a microservices architecture. And even if you do maintain some monoliths within your organization, there are many reasons you may do this, right? A few of which may even be good. But even those monoliths will need to communicate. By the way, keep up. I'm going to be throwing some stuff at you kind of out of the corner of your eyes there. So, even those monoliths will need to communicate with external services and systems. Most of the time when that happens, it's via a REST API. And REST APIs have enjoyed a long and a very good and successful run, right? They have a lot of advantages. As Jeff Bezos' famous memo pointed out from several years ago, he required all functionality in Amazon to be exposed via service interfaces. And he didn't specify REST per se, but by laying things out in the way that he did, it kind of led very naturally to a lot of HTTP-based APIs being used. I like to show this. This is a Bezos mandate, and for such an iconic memo that came out, it's very difficult to find details on this. I actually found this from a former Amazonian, but when I found it, it actually had one more thing on the bottom, which was after he laid out all the things saying everything has to go to a service interface and all that, he wound up with, anyone who doesn't do this will be fired. Good to be king, right? Then the last point on it was, thank you, have a nice day. I didn't realize at first that was a joke. Okay, the former Amazonian had included that, and then he listed the caveat saying, that last part I just added because if there's one thing Jeff Bezos doesn't care about, it's your day, right? So I found that kind of interesting, maybe a warning to the rest of us. But anyway, the edict came down that everything had to be exposed via service interface, which happened very quickly, obviously, with the last point, that anyone who doesn't do it will be fired. So very good motivation. But again, REST APIs kind of became a very natural beneficiary of that. You may also have heard of the 12-Factor Manifesto. This was produced by Heroku engineers. Heroku as a platform as a service. And again, it wasn't necessarily specified at each juncture that it should be an HTTP-based API, but it was kind of implied, right? And again, a huge beneficiary of it. So the upshot is that REST APIs have enjoyed a pretty good run. And are still very useful, very valid, very successful in most cases, but they're not universal, right? There are certain drawbacks that they have. For instance, both services in a two-service communication must be available and online at the same time. In terms of scaling, you typically have to scale roughly linearly because you have a certain number of connections that you must maintain or must be able to reach, I should say, when traffic spikes or surges. You also have some certain problems when the network isn't sufficiently performant or stable, because when that happens, things drop out. What also happens when a particular instance dies on one end of that interaction? Ooh, interesting. So reliability is a concern, resilience is a concern as well. Messaging platforms reduce or eliminate these concerns in many ways. Messaging platforms are typically considered part of your critical infrastructure, which means your cloud vendor or your critical infrastructure team keeps them alive at all costs, right? It also allows you to detach temporally and locationally, because both services don't necessarily need to be online in that communication, in that interaction at the same time. Producing service, a service that produces a message, let's say in this case, can dump that into a queue, and the consumer of that same message may not even be online at that point in time. When that consumer comes online, it doesn't necessarily need to know where that message came from or when. It just knows it has a message to consume. So it allows you to detach temporally and locationally. It also allows you to scale independently, because if your consumers are being overrun, if they can't keep up, you can scale out on the consuming side, but not necessarily on the producing side. So it gives you a lot more flexibility in terms of your architecture and a lot more scalability and resilience and so on. So very quickly, some examples of leading messaging platforms. I always kind of can point to the big five. There are more, but these are the ones I think that are kind of primary. RabbitMQ, of course, has been around a long time, well-proven, excellent scalability, very robust. RabbitMQ uses AMQP, Advanced Message Queuing Protocol, as well as a handful of other protocols. But AMQP is kind of the daddy rabbit. Yeah, I know. Apologies again for people who heard my terrible jokes yesterday. You're going to hear more. Brace yourselves. But anyway, AMQP is the most important protocol probably in the stable of protocols RabbitMQ supports for enterprises. Then you have Kafka, Apache Kafka. Anyone heard of Kafka? Yeah, nobody, right? Kafka is big. Kafka is very robust, very well respected for good reasons, but that is widely established, as well as some interesting side effects, which I'll cover in a moment. You have the big three cloud providers. Amazon has Kinesis, Microsoft has Event Hubs, and Google has Google Cloud PubSub. Most of these other bespoke or one-off solutions that are provided by a public cloud vendor will typically support AMQP or offer a Kafka API, which again points back to those as being what I consider to be the first among peers. But all of them are equally, well, I shouldn't say equally, all of them are very important to consider, right? As well as, again, a handful of other entrants into the field. But as you might imagine, one size doesn't fit all. So sometimes you see various different ones of these being used in various different contexts. Or maybe your company is standardized on one or the other, or a couple maybe. So you may have a company, your company may have standardized on RabbitMQ, or maybe Kafka. Maybe your company buys another company that is standardized on the other. If you're on RabbitMQ, they're on Kafka. Maybe you use both. Maybe you use Amazon Kinesis in certain cases and Kafka in certain other ones. It gets to be a little frustrating, right? Because we're the ones who have to write all that glue code and make everything talk. It would be really cool if there was a tool set that allowed you to abstract above that, so you could focus on the business problem at hand and not necessarily worry about the plumbing. And there is Spring Cloud Stream. It's all open source. I'm not here to sell you anything, but I am a huge, ardent fan of the technology because I think it allows you, I know it allows you to focus in, again, on what you're trying to accomplish. If you need to get it below the surface and tweak the levers and knobs, you can, but you don't have to, which is pretty sweet. So I kind of covered all of that. Oh, binders. What makes that all possible is a binder construct. The binder actually interacts, serves as a bridge between your program and the drivers for a particular message queuing message platform to allow you to abstract above that. So you can swap those out as need be. What's really cool is if your needs change, you can swap those out with a rebuild. And if you've really thought ahead, you don't even have to do a rebuild, which is also pretty nice. I've kind of already covered this as well. I'm trying to kind of move through this so we can get into the good stuff and see it in action. But it also gives you some insulation. Let's say that your CTO reads a virtual tech magazine and says, oh, we need to move to fill in the blank. So this can happen, right? And sadly, it does on occasion. But the good news is if you planned ahead, well, I mean, you can swap this out with a rebuild, swap out a different binder, swap in a binder, do a rebuild, and you're off and running. If you've planned ahead, you can actually do that dynamically. You don't even have to do a rebuild, which is really amazing. Hopefully, none of us will be in that situation. Or if we are, it won't be very often, right? Because otherwise, we need to break out the tranquilizer darts. But it's good to know the power is there if you need it. So really quickly, kind of what I'm going to go into and show you. Depending on timing, there are a lot of things I want to show you, but we'll see how far we can get into it. I'm going to use Spring Cloud Stream with some messaging platform. I'm going to start off with Rabbit. And as you can see, there are three different things I've defined here. These are three different microservices I'm going to build, and I'm going to use the interfaces predefined in Spring Cloud Stream. Now, if there's time, I'm going to build a separate interface just for fun, right? And show you how easy that is as well, because you have a lot of power at your fingertips with this. But predefined in Spring Cloud Stream are three interfaces. One is the source, which is the producer of things, right? It produces messages of whatever type and shoots them into a pipeline. And I'll try to maintain that terminology at that level, pipeline, versus going into exchanges and queues and topics and mix and match and all that. But the idea, of course, is the same. Regardless of what your plumbing is, you're going to have something that creates values and pushes them into that pipeline. You also, on the other end, have a sink. A sink will consume those values and do something with them, right? That's the end of the line. Then you may have one or more processors in between, which will grab messages, process them in some way, that's the term processor, and then pass them on to various different sinks. And we'll start off, and I'll just build that with Rabbit, which looks a lot like yesterday, right? But I'm going to use the current kind of standard way of doing things versus that kind of exploratory way that I showed you yesterday as well. And then we'll talk about scaling, and I may mix and match some of the order of this, but we'll cover the scaling as well. So you can scale out. If you need more processors, if you need more sinks, if you even need more sources, you can do that as well, and it's very simple and easy to do that. Then we'll play bad CTO. We'll decide that we're going to swap our standard and just pull out Rabbit and throw in Kafka. Any managers, bosses in here? Oh, okay. All right, well, who let him in, by the way? Okay. Repeat after me. With great power comes great responsibility. I'm going to show you how to migrate. And if you, sir, would maybe step out at that point, I don't know. I don't want to ruin your day or anybody else's. But we'll show you how to do a migration. It's, spoiler alert, it's pretty easy. But anyway, you can decide on how you want to estimate that later. Wink. And then we'll talk about versatility. We'll show how you can actually integrate between the two, in this case, RabbitMQ and Kafka, but certainly the same applies with Kinesis or Event Hubs or what have you. So let's code. Right? This is my seat. That's the hot seat. Everything I do is live code. Most of the things I do actually work. So we'll see. Hopefully this won't be one of those days, but you know, sometimes. Okay. Oh, I need to mirror, don't I? That might make it much more useful here. Okay, so that's pretty good. Let's. Yep. Okay, so. Okay. Well, this is your starting point for Spring Boot-based microservices on the web. This is the Spring Initializer. If you haven't been there and visited this site in a while, you may be thinking, no, it's not. This changed actually a couple weeks ago. It's all new. It actually changed again last night. So we're trying to take in feedback because as with all changes, you improve. Your goal is massive improvement. But once in a while, you miss something or something is missing that you left off because you didn't think it was necessarily on the critical path. So we got some good feedback. We've modified things. If you have additional feedback, please do let us know. It's all good, right? But this is kind of where we are. This is your starting point for Spring Boot-based microservices. You don't have to go here. You can curl this. You can HTTP this endpoint. You can use it from your IDE. You can even write every line by hand as if it were your own child. But it's not terribly productive to do that, right? So we'll kind of skip ahead. So you even here in the simple version, and of course you can blow this out and choose a lot of different options, but you don't have to. Again, it's like Spring. Everything's Spring. It has opinions, and it helps you get started faster, that 80 to 90% use case. So even here, though, you have choices. If you are a Maven developer, you can create a Maven project. If you're a hipster, you can create a Gradle project. Now, I already ditched my hoodie, so I'm going to stay with Maven today. I'm not feeling the hipster, but you know, sometimes, especially when I'm doing Kotlin development, just Gradle works, right? But we'll stay Maven today. We'll also stay with Java today, and I'll stay with the current version of Spring Boot 2.1.3. But of course, you have options with the upcoming milestones and snapshots, and then the previous version. I'm going to change the metadata so I can just put this to my domain because it never works otherwise. I'm kidding. It works fine. I just like my domain in there. Okay, so I'm going to create a source here. So let's say we'll do keynote source, and I'm going to bring in some dependencies. I'm going to bring in the web dependency, which gives me the ability to create a web-based application. Let's see, I also want to bring in Cloud Stream. There we go. And then I'm going to bring the dependency for RabbitMQ and Kafka as well, and then Lombok. Because I'm a lazy developer. Lazy good, not lazy bad, right? I've had a love-hate relationship over the years with Lombok. I love certain things about it. I don't love other things about it, but it works pretty well. And for demos, it allows me to focus again. Oh, didn't this happen yesterday? It's always the same spot. Oh dear, okay. So let's see. It's like somebody doesn't like me. Okay, so here we go. We're back. That's good. So let's drop this on the desktop. Whew. No pressure. That's an ominous sign, you know? It's what could possibly go wrong? Oh yeah, everything. All right. So all right, let's open that up. And we'll open this in our favorite IDE, NetBeans. Just kidding. I like NetBeans. I mean, I dish on my friends, right? NetBeans is an awesome IDE, has great Spring support. Anybody use NetBeans? Yeah, it's good, right? Anybody use Eclipse? Really? Could be worse. Could be Emacs, right? Anyway, no, Eclipse is pretty awesome too. We actually have a build of Eclipse called Spring Tool Suite, which has some really great cloud deployment capabilities. And every time somebody shows me the latest, greatest of that, I go, oh, it looks so nice. But I love IntelliJ. It just works for my workflow, and of course has great Kotlin support as well. So that kind of is what keeps me come for the Kotlin. Okay, so this is my source project. I'm just going to go in and create a few simple default properties that kind of get me up and running very quickly. So I'm going to assign my server.port, there we go, took a little while there, to 0 so I can scale it if and when I need to. I'm going to assign my bindings, and again, with Spring Cloud Stream, there are 3 different interfaces predefined for you. Your source, your processor, and your sink. This is our source, right? And our source has what? It creates value, so it only has an output, right? By default. So I'm going to bind to my output, and of course I can set my content type to something like application/JSON, but I don't need to because that's the default. So I'm just going to put that, just going to comment that out, and then I'm going to change this to my destination, and we'll assign a destination of a pipeline named processor, right? And then let's see, what else do I need to do? For when I do switch off to Kafka, I'm going to do an auto add partitions true. That way I don't have to go in and physically add those partitions every time if I want to change something. Spring Cloud Stream is kind enough to provide that capability for me. And then I'm going to assign a minimum partition count of 4, which should get me up and running quite nicely. I'm then going to go to my POM, and I'm going to just do a little bit of a rearranging here, right? Because what I've got now is my Kafka binder and my Rabbit binder, and then of course my drivers for same. And I'm going to just group those together just for convenience here. And that way I can keep track of them a little bit better. I also, though, because right now we have 2 sets of binders. And Spring Cloud Stream builds on Spring Integration, which gets all the hooks, right, to the various different components that it deals with. But it also is based on Spring Boot, which has 3 huge things. One is its dependency management. One is the deployment, ease of deployment with the fat jar, which of course you can tweak, you can change, but that's kind of nice. You can deploy it anywhere, literally anywhere with a JVM. And the third is auto configuration. Now, auto configuration will go through and check your class path, your code, your annotations, and it'll say, based on what you have here, here's what I think you want, and it'll provide that capability very nicely for you. It'll spin up various beans to support your use case. But of course, it makes assumptions based on what you've provided. We have 2 binders in there. Which one do you think it's going to pick? It doesn't know. It's waiting for a bit more help from you, right? So I'm just going to comment out 1 binder, and that way it knows, hey, you want to deal with Rabbit, because that's the binder and driver on your class path. Very simple, right? So I'm going to next just go to my, whoops, not that. Yeah, there we go. I'm going to go to my, my code, and let's write some code here. So I'm going to create a class called Coffee. You knew I wore this shirt for a reason, right? All right. I always try to dress appropriately. So we're going to create a coffee machine, and we're going to push coffees through our pipeline, because this is the best part, right? And we'll be there to catch them on the other end. So I'm going to just create a few member variables here. So private final string. We'll need an ID. I'm going to keep track of my roast type, right? And my coffee name and a modifier. I'm also going to, as I mentioned, use Lombok at data at allargs constructor, which at data gives me my getters, setters, equals, hash code, and 2-string methods. And my allargs constructor asks Lombok to provide a constructor with all arguments, with an argument with a parameter for each of my member variables. So that's pretty nice. It keeps things nice and tight in my code. And then I'm going to just, because we need some values to work with, I'm going to create component, if I can type. I always count on the front row to catch my typos before I hit build. So if I typo, please, it's on you, okay? Please catch those. So I'm going to create a coffee machine here. Coffee machine. Sweet. I just love the sound of that. Okay, so I'm going to now create some string arrays here, and we'll say for our roasts. So we might have a light roast and a dark roast and a medium roast. Clever, right? Roast, an Italian roast, and a French roast. And we'll just split those, and that should be good. All right, so the next thing I want to do is have a string array of names, right? This is the critical part, right? Garbage in, garbage out. We need some good coffee names here. Who can help? Yes? Oh, anything. That'll work. Okay, Colombian. Okay, oh, Colombiano. Let's see, Ethiopian, right? Spelling is also a thing. Oh, bien. Whew. Couldn't you have picked easier? Okay, Guatemalan. Okay, Kona, right? If anybody's a Hawaiian coffee fan, I'm not. Sorry. What? Brazilian. Excellent choice. Brazilian. Okay, yeah. Oh, well, if you're going to go with that, we'll go Café Cubano, see? Cuban. What? Java. Okay. We can do that. The obvious choice. Yeah, I love it. Okay, yes, really good coffee. Can't beat that one. We'll stop there. How can you pass that? So and also we need a string array of modifiers. Now this is so we can charge more for our coffee, because that's what all enterprising coffee producers do, right? So we need a select batch, black label. That ought to double the prices, right? Let's see, premium blend. Limited run. Yeah, that'll work. Okay, so we'll just split those. And what was it? Oh, yes, okay. Platinum. Okay, platinum edition. Okay, we'll do that. All right, and then I also want a randomizer here, so equals new random. And then we'll just need some counters, right? I equals 0, j equals 0, k in this case equals 0. Okay, so now we need to create some coffees. So I need to generate some coffees, so we'll just, let's see, pour. Yeah, I like that. We'll go with the full-on coffee metaphors here. So what I'm going to do is just, let's see, return new coffee. We'll use uuid.random.toString to get our ID, and then we'll take our roasts. Oh, actually, I just kind of blithely skipped over something, right? Because I need to set my I equals to random.nextInt of, how many do we have? 1, 2, 3, 4, 5, right? So 5. And then, actually, I'll just duplicate those. Sweet. So J, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8. Not bad. 58. Yeah, that won't work. And then select batch 2, 3, 4, 5. Once again, 5. All right. Okay. Sweet. Okay, so roasts, we will return the ith element. And then names, we'll grab the jth element. Jth, I love it. And then modifiers, we'll grab the kth element. And that will be that, right? So that's our coffee machine. Now we just need to push those values as they're created into the pipeline. So I'm going to enable binding to my source.class, and then, let's see, I'm going to enable scheduling. So that will, oh, yes, thank you. Whew. Enable scheduling. Sometimes I get so excited, I just launch right in. So this will be a class for, let's see, coffee producer. All right. Oh, you know what? Barista. Okay, so now I need to inject my source, so I can use that. I also need to inject my coffee machine. Nope, coffee machine, machine, and then I can use Lombok for my all-args constructor to go ahead and inject those into my constructor. Keeps the code nice and tight. And then let's get started here. So I'm going to schedule. I'm just going to create a scheduler here at a fixed rate of 1 per second. I think that's 1 per second. It's either that or 1,000 per second. We'll find out shortly. So then I'm going to just create a method here to serve. There we go. Okay, so I'm going to use source and output and actually send. And then I'm going to use our friend, the message builder with payload. I'm going to use my machine to pour some coffee, build my message, and send it. Super simple, right? It actually is. Most of the stuff that I did was just to create those wonderful coffees that are going to be flowing through our pipeline. So now let's go ahead and go back and create our processor. Oh, I lost all my settings. I'm going to create my processor here, the Hecklers and K processor. That's fine. What's that? Oh, it is gone. Holy cow. Let's drop back on there. Okay, so web. Okay, and thank you very much. Cloud Stream. Cloud Stream. And Rabbit, Kafka, Lombok. Sweet. We have everything. Generate project. And just because I'm concerned now where we're going to go with this, so this will be my sync. We'll do the same thing. We'll generate the project. Yay, we got it. Okay. All right, so let's go back here. We'll unzip our processor. We'll open that up. And yay, IntelliJ. It's weird like that. And we'll go back to our full screen. Nice. Okay, so we'll go to our application properties. Once again, we want to be able to scale, so I set my server port equals 0. This is a processor, right? So the processor has bindings to what? It has bindings to an input channel and an output channel. So we're going to be getting those values via a pipeline, and we're going to be transforming them and then pushing them out via another pipeline. This so far looks familiar, right? So input, destination, and our destination is processor, as we defined earlier. So that's where we're going to be waiting for these. Processor. I have a group, which allows me to do the competing consumer pattern and scale out. So the more consumers I add, they alternate. Which is a good pattern to have, right? So that way you can scale out. I'm also going to bind to my output channel and provide a destination of sync, so I can access that as well. And then my auto-add partitions for Kafka, when we use Kafka, once again, is set to true, and then we'll go with 4 partitions. Go back to my POM here as well, and then we'll do our little bit of POM cleanup. I'll grab my AMQP dependency and put that right there, and we'll grab my Kafka dependency, my binder rather, and move that down here by my Kafka driver, and then we'll just comment that out again for now. So we'll go back to our code, and then once again, let's create our domain at data, at all-args constructor, class coffee, private, final, string, ID, roast, name, modifier. Sweet, okay. Now, for our processor, we need to define a message endpoint. So let's bind to our processor interface. And then let's set this to be a message endpoint, right? And this will be our coffee, coffee transformer. That's fine. Probably fine. Okay, so we need a stream listener, right, for our our processor dot input, and we need to indicate where we're going to, I did it again. Look at that. I get so excited. Okay, and we're going to send this to our processor output queue, right? And once again, we're going to be passing on objects of type coffee. We'll transform that coffee. And now that I think about how that sounds, that doesn't sound so hot. But okay, we'll just go with that. In coffee. Don't read too much into the metaphors, please, because we're going to be producing out coffee momentarily. So we're going to take our in coffee and we're going to create an out coffee. Out coffee equals new coffee, right? And we'll take our in coffee and we'll get the ID. We'll take our in coffee and we'll get the roast. And let's do something pretty simple here. We're just going to de-emphasize everything but the name, so we can really highlight that name and again, maybe draw them in on that. So we're going to just send that to lowercase, convert that to lowercase. We'll take our name and we're going to just blast that to uppercase. And then we'll take our modifier and once again to lowercase that. It's nothing fancy, but it works. I'm going to just print that out coffee, and then return the out coffee. Okay, again, pretty simple at this point for our processor. We'll keep it simple just to keep the flow going because the fun stuff, the important stuff is not in what I'm doing, it's how, right? Okay, so we'll go back now and we'll create our sync. Open that project and open that in our IDE once again. There we go. Okay, application properties. Actually, I want to go to my server, port 0. Boy, I just can't. There we go. Okay. Spring Cloud Stream bindings. This is a sync. It only has inputs, right? It doesn't do anything to pass it on. It does something to consume it. So we're going to set our input destination equal to sync. And once again, we'll set our group the same so we can scale. We'll set our Kafka auto-add partitions to true and Kafka minimum partition count to 4. And then we'll go to our, oh, actually, I need to go to my POM, don't I? For the same reason. We'll grab these dependencies and reorganize them just a skosh. And we'll grab the Kafka binder and move it down. There we go, and we'll comment that. And then let's go to our code. Once again, very quickly, our domain, class coffee, string ID, roast, name, modifier. Sweet. Okay. Now, again, for similar to our processor, we need to define a message endpoint. So we're going to bind to our sync class, and we're going to make this a message endpoint. So this will be our coffee drinker, right? We're going to consume this on the other end. And of course, we need to have this be a stream listener to sync.input. And let's see, we'll just consume this, so drink. And this will be expecting coffees to come in. And we'll do something pretty simple. We'll just print this. Whoa, back off. We'll just print this out. Okay, let's go ahead and run this and see what we have. Front row, hope you haven't let me down. No pressure. Okay, look at that. That's running. Oh, so exciting. Okay, so here's our processor. We'll go ahead and start that as well. That's up and running. So let's go to our source. And then we'll start that. And once that's running, then we should be able to hop back over to our processor. And we see that we are indeed lowercasing everything except for that name, which we're highlighting. That's uppercase. Let's go to our sync and make sure it's getting it too. And it is, of course. We don't make mistakes. Not with the front row on my side, we don't. Okay, so I'm going to stop the, come on, there we go. I'm going to stop the producer here, my source. And then let's do some changes. Let's play CTO, right? Because what happens if, now that we've done this all in Rabbit, if our CTO says, oh, Rabbit, that's so yesterday. Let's do Kafka. So let's see what it would take to do that. So let's go to our POM. And as you might recall, we commented out the Kafka binder and driver. So let's uncomment that. And let's go back to our Rabbit binder and driver, and let's comment that out, right? So let's restart that. And while that's restarting, this is our processor. We'll do the same thing. So we'll go to our POM. We'll uncomment Kafka, binder, and driver. We'll recomment Rabbit, and we'll restart that. And then we'll go to our sync and do the same thing. And there we go. Okay, so let's see where we are with this. Oh, did I not restart that? Oops. Okay, I did restart the source, so that's good. And there's our processor. Yep, and it caught up. And then we see in our sync, it also caught up. So a couple things to point out here. You can see that I declared earlier that I wanted a minimum of 4 partitions in Kafka. I guess the first thing to point out is that, yes, we're actually running on Kafka. And by the way, I'm running all these locally right now, but if we have time, I'll go ahead and throw some over to a cloud-hosted instance, let's say of Rabbit, for instance. But we can see here that we're running off of Kafka now, and we also see that we're bound to all 4 of these partitions. The minimum partition count was 4. We have sync 0 through sync 3 right there. So everything is working as intended. That's great, right? So let's go back now, and let me go back to my source. And we'll stop that. Now, what happens if you, let's see, do I want to do this yet? How much time do I have? 5 minutes. Oh, gosh, tons of time. Okay, so we can just go bananas here. All right, so I'm going to go back to my source and just restart that. Because what I think is really kind of nice is how easily this scales. And I've already shown you some kind of cool stuff with a quick switch. By the way, the manager, you didn't see that. You did not see that. Okay. So if your manager, your boss, comes to you and says, how long will it take to completely replace all of our infrastructure and go from one to the other? Just remember, credibility is hard to win back, okay? So, all right, so we're up and running now. We have our source producing values, pushing them to a Kafka topic, our processor grabbing them, manipulating them, passing them on, our sync also grabbing them, again, via a different Kafka topic. But what happens if we want to scale this? So let's see, I need to pull this out of presentation mode. There we go. So there's my source, and there's my processor. I need to change the configuration where I can have parallel runs here. And then let's fire up another instance. And since I only have 5 minutes, I actually won't go too crazy with this. But here we have 2 instances running, and we can see that now this first instance that we had going, let me zoom over here, actually is covering 2 partitions, processor 2 and processor 3. If I go back over to my new one that just spun up here, let's see. There. Where did it go? There we go. Processor 0, processor 1. So it automatically handles splitting up those partitions based on the number of instances you have. Very nice. Just adds a very nice amount of ability to scale pretty simply, right? Okay, so let's mix it up a little bit. I'm going to go ahead and kill one of these off, which, by the way, once I do that, then I can go back here, and I can see that, once again, this picks up all 4 partitions. Processor 0 through processor 3, automatically. So it handles that quite nicely as well. Okay, so now, what happens if we have to mix and match? What happens if we have some stuff in Rabbit, and we need to do something with that and pass it into a Kafka topic? Well, that's also fairly straightforward. Okay, so I'm going to go back to full screen mode or presentation mode, because that actually is a pretty nice, makes it a little easier to see. We'll go back to our POM for our source. I should probably stop that. And I'm going to bring Rabbit back, and we're going to push values from our source into a Rabbit exchange, right? And then if I go back to my processor, that is my processor, right? Yes, it is. Okay, so if I go back to my processor, what I want to be able to do is listen to one pipeline via Rabbit and push to another pipeline via Kafka. Cover your ears, please. All right, so now I have both sets of binders and both sets of drivers on my class path. Now what do? How does the boot autoconfig decipher what we want to accomplish? Again, that's where you need to provide a little bit more information, because what we want to do is listen to a Rabbit exchange and topic, right? So Spring Cloud Stream bindings input dot binder. So we just say, hey, this is for Rabbit, right? And then here for our output, we're going to leverage Kafka. So once again, we'll use the Kafka binder here, and that's enough information. It's so easy. It lets you focus on what you really need to do business-wise and what you really want to do. Go drink coffee. So that's kind of nice. All right, so we have our processor running again. Let's go back here to our source. We'll run that again. And while that's booting up, we can just take a quick look here. And we see that, yep, there's our Kafka initialization. And up here is our Rabbit. Where's our Rabbit? Back down. Yeah, there we go. So here we're using, we're accessing Rabbit. Have a Rabbit connection factory firing up and connecting. So, and there we have it. We're running. So we're producing values, pushing them to a RabbitMQ exchange/queue. We're grabbing those off with our processor and we're passing them on to a Kafka topic. So simple. All right. So, a couple of minutes? All right. So actually, there were a couple other things that I would really have liked to have shown you. One, it's super easy to define your own interfaces. If you're interested in finding out more about that, see me afterward, because I showed you kind of the simple path, and that works like 90+% of the time. But what happens if you have a processor that you want to read from various different queues? What happens if you have a processor you want to push to various different queues or topics, exchanges or topics? And all that's certainly doable. It's configurable as you wish it to be. So that's kind of nice and super easy to do as well. So again, come see me. If you want to switch to a cloud, let's do the cloud thing really quickly, right? Why not? So let me stop that. And I'm just going to, what's that? Oh, good. OK, I thought, all right, so I'm going to grab this. Nobody look at this, right? OK, so this is my, my Rabbit, my cloud-based Rabbit hosting information. And there's my source app. And I'll just paste that there. And we'll run that. It's a cloud-hosted Rabbit instance, so we'll see if that works. Again, all I'm providing is 4 basic properties: my host, my virtual host, my username and password, and everything connects, or should connect. And there we go. So again, super, super, super easy to do, whether you're running it locally, cloud-hosted, doesn't matter. It just works. OK, so getting back to wrap up, just in the nick of time, right? OK. Here are some helpful resources, I hope. The first is my repo with all the code that you saw and then some. I will be adding to that periodically as I think of more things to add that I think are cool, because all of this is actually cool and useful driven development, right? Stuff that I find useful, stuff that I find has a lot of power in your hands so that you can do stuff that you want to do, and again, that your business needs versus like concentrating on learning more about Kafka replication or something. So there's the code. So please watch that. That way you're notified as changes hit, as soon as they hit. The Spring Cloud Stream doc page and project page, that also gets you jumping off point to the code repo for Stream, as well as the documentation, the API docs, and what have you. If you need to reach me, by all means, please email me, but better yet, tweet me. So thank you very much for coming, and thanks for inviting me again to Vox Days Bucharest.
Thank you. Thank you very much. No, I don't have sound.